exponent.
All right, so at the bottom of your toolkit, make sure that you write these 4 words down. We're going to take a moment to make sure we know what they mean. Okay, so exponents are powers, and you did have a couple examples at the top, like x squared. That's the exponent, right? What about a different word? We understand that a variable is a letter. Okay, almost always. We could actually use different things, but we always use a letter. And that letter represents a number. So we did have examples of those up top. We have x's. We had y's. I think that's all we had. All right, what about the others?
Oh yeah, because like a variable changes, but constant, the number stays the same.
Very good. That's a great way of thinking about that. Variables change. Variables change from problem to problem, don't they? X on problem number 1 might be different on problem number 2. But a constant stays the same. The number 5 will always be the number 5, so it stays the same, and that's why they're called constants. Okay? It's the number in front of a variable. All variables have coefficients. No constant has a variable. Okay? All variables have a coefficient in front of it. But no constant, or I should say all constants, have no variables. Say it that way instead. Okay? So on the top of your toolkit in the like terms page, which ones of those are coefficients? So we recognize just by patterns and from the past that like terms have exactly the same variables. Exactly the same variables, x and x, or x squared y. Okay? Whereas over here, a constant and a variable term will never be a like term. And here you recognize the exponents don't match. Okay? And of course, obviously, these one are 2 different variables. So let's go through and let's add some stuff up. Okay? What would 5 plus 7 be?
13.
How about 12? All right, 5 plus 7 is 12. Does everybody agree with that? Okay. You can add 5 plus 7, can't you? You've been doing it for a long time. So you can add like terms. What about 2x plus 8x?
10x.
It is 10x. Now, some people don't write it like this. But really, what are you adding when you do 2x plus 8x?
2 plus 8.
You're not adding the x's.
You add the numbers.
You're adding the coefficients. You're adding the coefficients together. Okay? But I know that you never, ever, ever write it down this way, do you? Most of the time, this is what happens in our head, and this is what happens on our paper. Okay? So just keep that in mind. Keep that in mind here with this next one. What about 3x squared y minus 7x squared y?
It'll be 4x squared y.
Close.
Negative 4x.
Negative 4. Remember, what are the 2 things that you're actually adding together? 3 minus 7. You're doing the coefficients together. The x squared y doesn't change, does it? But this part is supposed to be happening in your head. Okay? So what is 3 minus 7? We decided it was negative 4. So it is going to be negative 4 x squared y. And then I love the last problem. Some people get the last one mixed up. What do you think?
Would it be 1x? 2x.
So this is 1x,
Oh, so it's just 2x there.
and this is another 1x. So what are you adding together? 1 plus 1, right? And again, 1 plus 1 happens in your head. The 1 plus the 1 happens in your head, but most of the time we don't put that there, and we just put the 2x instead. Okay? Adding like terms, adding and combining like terms. Now what about over on the other side, the unlike terms? I should have done these kind of mixed them up, but I forgot. When you add x plus y, what do you get?
X, y.
1x, 1y.
Yeah, you get exactly what you have. You have an x plus a y. They're not alike, so you can't add the coefficients together. You can't put them together. You just actually really have to rewrite it because it's as simple as it gets. You're not allowed to combine two variables that are not the same. All right, I got one more right there. It should be an answer by now. I hope you understand the pattern and the whole point. When you add 4xy squared minus 4yx squared, what do you get?
4x squared.
All right, thank you. And again, okay, everything just has to stay the same because they are not alike. So that's all you can do. All right, so that's all you can do. All right, I'm going to give you as much time in class today as possible. So I got two problems right here, two more examples at the bottom. And then we're going to look at two together from your actual homework, and then we'll get started. All right? So I got 3x plus 7x, easy enough, right?
2x.
All right, here's what I want you to do. A little bit different, okay? Because this is how I want you to do it on your homework. Let me get that to you. You can keep, those are your notes, okay? I don't plan on doing your notes in your toolkit very often, but this one it was easier to do that way, so I thought I'd go ahead and do it that way. All right, use your toolkit as help. What I do not want you to do is I do not want you to do your homework in your toolkit, okay? So if you want to use scrap paper, don't use your toolkit,
We can't write on that.
okay? You can write on this, that's fine. But if you need to use a piece of notebook paper, some people just like doing their work on notebook paper, then you need to get out a different piece. Do not use your toolkit. Yeah. Do not use your toolkit to write on for your homework, but you can use your toolkit to help. All right. You're going to do both sides, but let's get started.